Hi, my name is Reza. This video is for MRI course project and I'm going to talk about fast spin echo sequence in magnetic resonance imaging. This is my outline. I'm going to talk about conventional spin echo first, and after that I will explain about fast spin echo. You may know there are many sequences for T2 weighted imaging. Spin echo is one of the basic pulse sequences for T2 weighted imaging. However, it takes several times to get an image, so people invented fast spin echo to reduce the scan time. I will explain spin echo briefly. In the sequence, we have a RF pulse, and after that we have a refocusing pulse. Just after 19-degree pulse, magnetization completely tilts on transverse plane, and the spins you can see in this figure, and the spins start to dephase. This dephasing spins get reversed after RF pulse, refocusing pulse, and this refocusing pulse will cause to invert the spins, and the spins will get coherent again and generate an echo. This is the main principle for spin echo. Fast spin echo sequence is an extension for conventional spin echo. This sequence has a train of refocusing pulses instead of just one pulse. After each refocusing pulse, we will get an echo. You can see in this picture, after each of the refocusing pulse, we will get an echo. And this echo signals are encoded with different phase encoding steps. Therefore, each echo fills one line of the chi-space. As you see in this picture, the green one, the green echo will be filled in green line of the K-space, and also the blue echo will fill the blue line of the K-space, and etc. So instead of filling just one line of the K-space, multiple lines will be filled in this sequence. Okay, let's compute the signal intensity in transverse magnetization and longitudinal magnetization. We have a RF pulse. Before RF pulse, we have the magnetization in Z direction with the amplitude of M0. Just after 19 degree, we have M0 in X direction, as you see in the formula. And then we have a free precision and also dephasing due to the field inhomogeneity, and we can get the formula you see based on cosine and sine of the delta omega tau. This formula is valid for just after refocusing pulse. Just before refocusing pulse. Just after refocusing pulse, the y component of this matrix will be inverted, and for the interval between two refocusing pulses, we have this formula. And if we put time t equal to 2 tau, we can get an echo between the two refocusing pulses. As you see here, we can get a echo at time equal to 2 tau, with the magnetization of M0 multiplied to e to the minus 2 tau over T2. We will get another echo in time equal to 4 tau and so on, in 6 tau, 8 tau, and depends on our train length. So this formula is for the transverse magnetization in an echo. We can repeat this approach for getting the magnetization in z direction, and you can see we have the magnetization in echo times, and finally we can get the general formula for signal intensity in echo times. That depends on T1, also T2, and TR. In this formula, F stand for a geometrical series that can be calculated from the intensity of the echo times magnetization in z direction. And this is our simulation for magnetization in also in transverse plane and in z direction. You can see the blue one is the x direction, the red one is y direction, and the green one is z direction. You can see in the time equal to 25 millisecond we have a refocusing pulse and y component get inverted, and we can get a echo in 50 millisecond. You can see in x direction echo will be occurred in x direction. And we will get another echoes after each refocusing pulses. You can see here we can get 1, 2, 3, and 7 refocusing pulse, but there is a limitation for the refocusing pulse based on T2 relaxation time. Okay, there are some advantages and disadvantages for the fastest pinnacle sequence. The most important advantages is the scan time in the sequence is very low, because we filled multiple line of k-space in each TR. So due to this low scan time, the motion artifact will be less problematic in the sequence, and also this sequence has higher SNR in comparison with conventional spin echo. But there is a main drawback for this sequence, and it's the higher SNR, because we have many RF refocusing pulse which cause increase SAR. Thank you for watching this video.